Go. This is the part 2 of the same video. The part 1 has already been released.
So this is, we are going to write this on the sigma notice. Sigma notice. What we have done over here, this is a plus x to the power n. This can be written as this sign is known as summation of sigma. Sigma k runs from 1 to n. Just a minute. K runs from means k starts from 0 to 1. This is how much NC 0 a to the power n NC, so just a minute, sorry, this is NC k into x to the power k. So this one is the sigma notation. So simply k runs from 0 to n, nck a to the power n minus k x to the power k. Just a minute, for just if you keep k is equal to 0, if k is equal to 0, this one becomes how much here? nc 0 a to the power n minus 0 x to the power 0. If we put over here k is equal to 2, then this one term become how much here? nc2 a to the power n minus 2 x to the power 2. So this is simply sigma notation, how we can write this one in the form of sigma. Okay, so this one is the fifth property. Now one more thing, few more direction properties also. Using binomial theorem. So this is how much here? 1 plus x to the power 6. Means what we are getting over here? First term is 1, second term is x, and n is equal to how much here? 6. So simply we can do this expansion. 1 plus x to the power 6 means how much here? The first term is 6c0 1 to the power 6. Second term is 6c1 1 to the power 5 and x to the power 1. Okay. Third term 6c2 1 to the power, this is how much 6 minus 2 means 4 and x to the power 2. Next one term becomes how much here? 6c3 1 to the power 6 minus 3 means how much here? 3 into x to the power 3. This is how much here? 6c4 1 to the power 6 minus 4 2 into x to the power 4. 6c5 1 to the power 6 minus 1 into x to the power 5. Now the last term is how much here? 6c6 1 to the power 0 and x to the power 6. So observe one thing. This is how much here? 0. Then over here we can write also this is how much here? X to the power 0. 1 then the power is 1. 2 then the power is 2. 3 then second term the power is 3. 4 then the second term power is 4. 5 then second term power is 5. Over here we are not writing 6 minus 1, 6 minus 2. It's obvious 6c1 we have to find. So 1 to the power 6, that is equal to how much here? 1. This is how much here? 5 itself. 1 itself. This is 1 itself. And over here is how much here? Power is 6. So just observe how many terms are over here. Just we have defined the property. 1 term, 2, 3, 4, 5, 6 and 7. So number of term is 1 more than the index. Sum of the power 6 plus 0 6, 5 plus 1 6, 4 plus 2 6, 3 plus 3 6, 2 plus 4 6, 1 plus 5 6, 0 plus 6 6. So this one is the expansion. I can write this one all the expanded form, and we can use the formula for this one. So simply we are going to remove this is 1, all the 1, so that will be easier for us. And now we are going to write this is our answer. What are the values of 61, 62, 63 and so on. We can use calculator also.
So
or-
why you have removed all those one power?
Yeah, so power. So 1 to the power n is equal to 1 itself. So n belongs to integer and n is not equal to infinity.
Okay, so that is the reason.
Yeah.
Thank you so much,
So
sir.
1 to the power n is 1 itself. N belongs to any integer, but n is not equal to infinity. 1 to the power infinity is not defined.
Okay.
So 1 to the power, we are writing over here. So this is simply we can write. One more thing. So one more property we are going to do. Just go through this example and then we can define. So 60, so go through calculator. How much you are getting? 61, how much you are getting? So just go through calculator. So I am explaining over here. So 6C0. So simply if we expand, we are getting how much here? We can use calculator, that will be easier for us. Otherwise 6 factorial by 0 factorial into 6 minus 0 factorial, and this is 6 factorial by 0 factorial means 1 into 6 factorial. What is we are getting over here? 0 factorial is equal to 1. 0 factorial is equal to 1. So finally we are getting this as 1. Clear? 61. So this is the first term from beginning. First term from beginning, the power 61, this is equal to 1. Now 6C1, 61 we are calculating, we are getting 6. Clear? 6C1 if we calculate, we are getting how much here? 6. Similarly 6C2. So if we are going to calculate 6C2, we are getting this as 15. So calculate this one. I am not calculating over here. 62 is how much here? 15. 6C3. 6C3. It means how much here? 6C3 means 6 factorial by 3 factorial into 3 factorial. So 6 into 5 into 4 divided by 3 into 2. So 6 cancels. So this is ultimately coming 20. So 6C3 is coming 20. Okay. So 6C3 is how much we are getting? This as 20. Now go for the last one from the last row. 63 is
20.
20. Now just go from the last. From the last 61, the last term is how much here? 66. So again this is 60 is how much here? We have got over here 60 is equal to how much here? 1. 0, the first term is 1. Now go for the last term. This is last term means 7th term. This is last term. Again we are getting is how much here? 6C6. Can we get how much we are getting? 66 is also how much? 1 only. Then after 6C1, we have got, right now we have got how much here? 6. So this is also equal to 6C5. 6C2 is we have got how much here? 15. And this is equal to how much here? 6C4. And the last one we are getting 6C3 is equal to 20. So simply what we can get, one more property we are going to deal. So 6C0, first term, the last term, the coefficients are same. First term and the last term, the coefficients are same. Second term and second last term, second term and second last term, the coefficient is same. Third term and the third last term, coefficient is same. Let us write over here. So first term is 6C0. 6C0 means how much here? 1 into x to the power 0 is also how much here? 1. 6C1 is how much here? 6 x to the power 1. 6C2, 6C2 means how much here? 15 x to the power 2. Then after how much here? 6C3, 20 x to the power 3. 6C4 is 15 x to the power 4. 65, 6 x to the power 5, and last term we have dealt over here 1 into x to the power 6. So what we can observe over here, first term and last term the coefficients are same. Second term and second last term the coefficients are also same. This is third term and third last term the coefficients are same. So this one is, we can know this one is also the first one property. So in any binomial expansion, the coefficient of first term and last term same, means coefficient from beginning and last are thus equal. From beginning first term and the last first term are same. Coefficient of from beginning second term and last second term is same. Coefficient of third term from beginning and third term from the last are also same. So this one is one property also. So this much for this 1 plus x to the power 6 etc.